Let's take a look at example 1 of 7-7. What is the factored form of a perfect square trinomial? Well, a perfect square trinomial results when a binomial is squared. So remember that a plus b squared is really a plus b times a plus b. And we learned previously that that means that we have a squared plus 2ab plus b squared. If you did not memorize that shortcut and you needed to go back and multiply this, then we would have a and b and a and b on the outside. And when we multiplied a times a, we get a squared, and a times b is a, b times a is a, b, and b times b is b squared. That results in exactly what we had here. When we combine our like terms, that middle term is 2ab. So that is exactly what we found right there. When we look at what happens when it's subtraction, we put an a minus b and an a minus b on the outside. When we multiply those, a times a, we got a squared. And a times a negative b is a negative ab. Negative b times a is a negative ab. And then negative b times negative b is a positive b squared. So notice when we rewrite that we get a squared minus 2ab plus b squared. So the only difference between these two is the sign of the middle term. So you either have a positive or a negative. So since we understand that multiplying binomials and factoring are really kind of inverse operations, we're going to see how this can result in a shortcut. First thing we need to do is we need to identify if the first and third terms are perfect squares. So this is step 1. Identify if the first and third terms are perfect squares. So in this case, we see that the square root of x squared equals x, and the square root of 49 equals 7. So we can say that that is true for this step. Step 2 would be to determine if the middle term equals 2ab. So our middle term here is 14x, and we need to see if that is the result of 2ab. So our a term, remember that this is a squared and this is b squared. So our a term equals x, and our b term equals 7, because that's the square root of 49. So we need to say 2 times a times b. So 2 times x times 7, that equals 14x. So we have determined that steps 1 and 2 are true. The third step is to write the square root of the first and third terms as a binomial squared. So that means that we're going to take the square root of the first term, which is x, and the square root of the last term, which is 7, and we're going to write that as a as a binomial squared. So this is a binomial and we write it squared. Now the last little trick here is to take note that this is positive, so this is positive. So if the middle term is positive, then our binomial will be positive in the middle. If you need this extra little note, you can write it. If you don't, you can skip writing that little piece. For part B, we need to ask ourselves, are the first and third terms perfect squares? So the square root of the first term is 3x. So 3x squared is the same as 9x squared. And then the third term is the same thing as 5 squared. Does the middle term equal 2 times a times b? Well, 2 times 3 is 6, times 5 is 30, x, and we know that that is negative in the middle, so we know we're going to have negative on our final answer. So this was true, and we have 3x and 5 squared. So notice we took the a term and the b term to plug in here, and then we took the sign from the middle. This was negative, so this was negative. Go ahead and pause your video and do the try-its and come back and check your answers when you're done. Thank you for pausing your video to check your answers. Notice that I did not show all of the steps here. And the purpose for that is because the reason in learning a shortcut is to save us time. So I can just ask myself what the square root of the first term is, and it is 2x. And what is the square root of the last term? It's 3. And the sign of the middle one, so I have 2x plus 3 squared. And over here, the square root of the first term is x, and the square root of the third term is 4, and the sign in the middle was negative, so I have x minus 4 squared. I still had to ask myself if these were perfect square trinomials, but once that was decided, I didn't actually have any other steps to show.